Alright guys, welcome back. This is the final video in our installation process. Okay, it depends on how much I'm talking because I might have to split it up into two parts. But after this video we will receive our first belt. And after all the patience, you absolutely deserve this. So in this video we finally want to talk about the Android Debug Bridge because this is maybe the most important command line interface we are facing during this course. Alrighty, so let's have a look how it works and what we can do with this one. Alright, let's go. Okay, so here we're having our smartphone and the laptop. And the Android Debug Bridge itself consists of three components. I mean, it's not related that you know how the Android Debug Bridge works, but if you're using a tool, I would like to have at least a basic understanding what's going on over there, okay? So therefore, I would like to give you a really short introduction into the inner working right now. So the first component is our ADB server, and this one is running on our Ubuntu VM on the local host on 5037 as default. So this has been already being installed during our installation process of the Android Studio and setting up the SDK. If the server is not running, it will be automatically started when we are triggering a command, for example the ADB shell command. Alrighty? Okay. Next we've got the ADB daemon, and this is in service running on the device. Once again, we do not have to set up anything. This is being done by the manufacturer and your operating system. So this daemon is running as default on your device. The ADB server is handling the connection to the real device or also to an emulator or this virtual machine. It could be one connection to a real device, or it could be also several connections. For example, if you also have enabled or started an emulator and a virtual machine. The last component is our ADB binary, so the binary which is within the SDK directory. And now if we're starting this ADB binary and we're calling in command, for example ADB shell, this one will make the connection to the ADB server and forwards this command to the ADB server. The protocol, by the way, the ADB protocol is simply just a text-based protocol. So we can sniff this, and I guess we will also do this later on. Yes, we will have a quick look into this one. I mean, it's nice to see, but we do not get much value out of this, okay? All right. So back to this one. The ADB client has sent this command to the ADB server. The ADB server is then handling the connection to the device, for example, this real device. So it sends it there. The real device is executing this command and replies back this response to the server, which forwards it back to the client where it gets displayed. In our case, we're having an ADB shell running afterwards. So this is the Android Debug Bridge, their components and the inner working in a nutshell. I guess this is all we need to know right now. Once again, we do not have to worry about installing something or setting it up. It has already been installed. All right. Next, I would like to talk about the connections to those devices because this can be sometimes a little bit tricky. The easiest way to get a connection is using a real device, plugging it in via USB and then executing ADB shell. Afterwards, we get our prompt and we are good to go. Perfect. This also works for the emulator. So let's say it's using an emulated USB interface in there. The point where it's getting problematic is if you're having multiple devices. So if you have an emulator and a real device being connected to the same system and we are triggering a command, for example ADB shell, then the command or the ADB server does not know which device we are targeting. I mean, even I wouldn't know which device I would like to target. I have to tell this to ADB, and this can be easily done with the serial number. So we can get the serial number by running ADB devices. This will fetch those serial numbers, and then we can simply use the serial number to address this device. So if we are having multiple devices connected, we need to call ADB-S, the serial number, and then the command we want to execute. If we are getting the order wrong, for example ADB shell and then the serial number, we are getting an error in there. So we have to take care about the order. Last but not least, there's one connection type which is also possible, and this is TCP/IP. So for example on a real device via Wi-Fi, or also if we're using a virtual machine, not the emulator, if we're using the Android x86 virtual machine. Then we need to use the TCP/IP connection, and this is also not that hard. So the thing we need is simply just the IP address of this device, and then we can use ADB connect and entering the IP address. So this will make the connection, the ADB connection, based on TCP/IP. Okay, and I would also claim that these are all use cases we could require right now. So at this point, I mean, it seems like we are done. So we know how the ADB is working and how we can make a connection to this device. But the ADB, the Android Debug Bridge, is capable of more. And there's a really nice topic which I also want to include, which is port forwarding. So let's also dip into this topic right now. So port forwarding comes super handy if you want to access a certain port on this device. Let's assume we've got the device and we've got a mobile application running on this device. This mobile application is opening in port. For example, this one here, 31,515. 415, this way. My counting is not that good. So 31,515, yes, this way. Okay. If you now want to connect to this port, it won't be possible because this port is only available on the local interface of this device. So if you try to connect to this port from our Ubuntu VM, then we're getting a denied. This port is not available for us. And this is the point where ADB forwarding comes super handy. So let's say we've got the following use case. We've got an application which performs some analysis on this device. For example, Drosa. Drosa is such a framework which assists us in analyzing mobile applications. And Drosa consists of two components, an application which is running on the device and also a client interface which is running on our Ubuntu VM. Right now we do not have the possibility to exchange those information. So Drosa is not able to connect to this application, to this certain port right now, because it's just listening on the local interface. To enable this port to be accessible from our Ubuntu VM, we could use the ADB forward command in the following way. So by typing in ADB forward TCP 1337 TCP 31415, we are using the existing ADB connection to this device to make this port accessible. So the command would do the following. It would enable a port on our Ubuntu VM, so on localhost, the port 1337, and all the packages we are sending to this port would be forwarded to the port 31,515 on the device. By having this set up, it enables us to talk to this port even if it's not generally opened to the outside world. So we are enabling some kind of local proxy on our Ubuntu VM, which has the ability to talk to this port. And by having it in this way, we can now interact with a service on the device, which is normally not being exposed. So this is pretty awesome. And I mean, we also require this during this course. When we talk about Drosa, for example, or generally speaking, if we want to have a port accessible from the device to our local machine. So this is the use case of ADB forward. The first port is therefore the port on the host system. So we've got the protocol TCP and then 1337. So this will be opened on the local interface. And the second port is the port on the device where we want to forward this traffic to. So in this case, 31,450. Yes, this time I counted correctly. All right. And then we could also have ADB reverse. And this might be now a little bit confusing if it's not already being confusing. But if you're doing some examples, I guess it will be more clear afterwards. Okay, let's also dip into reverse. So reverse simply just means the reverse process. I mean, yes, as the name already suggests, but what does this mean? How does this work? So this time we do not want to access a port on the device. This time we want to access a port on our Ubuntu VM, on our local system. So let's say we are running a web server on the local interface on port 8080. This web server is once again not reachable from the outside world because it has been bound to the local host. We can now make this port available to the smartphone based on the ADB reverse connection. But to be honest, this is something we are not going to use very often. So I guess I have used it 3 or 4 times within my whole career. So within the last 8 years of Android app hacking. Therefore, you already got the feeling that this one is not really required often. But nevertheless, let's have a dip into this one. So now we want to make this port available on our smartphone. And once again, we are using the existing ADB connection to this device to make this port available. But this time it's a reverse connection. So let's have a look into this one. Okay. If we are running ADB reverse TCP80 TCP8080, what happens is the following. This time it's the reverse direction, which means if we are now accessing the local interface on port 80 on our smartphone, then the web server will appear over here. So ADB reverse will be used to enable a service which is running on our local system or on our Ubuntu VM to the smartphone. So this is what reverse means. We are enabling a service which is running on our Ubuntu VM or on our local host to the smartphone. If you think back of forward, forwarding means we are enabling a service on the smartphone to our local host, okay? So yes, if you haven't been confused, you might be right now. But if you're taking a look at, let's say, the reverse example, I guess the whole principle will become clear. Alrighty? Okay. And therefore I would suggest let's have a look into a practical view into this whole ADB topic, because theory it's okay, but a little bit boring. Therefore, let's start playing around with this one on our Ubuntu VM. You ready for this? Then let's switch back.